All right. So we're going to pick up where we left off with yesterday's lesson. We're going to try a couple more, or at least one more of these linear programming questions. This one, of course, looks a little bit different. It's not a word problem. It doesn't give you a paragraph of information that you have to decipher. In fact, it gives you most of the information that you actually need. All right, it starts off, we want to maximize the function m equals 6x plus 3y, and what it gives me on the right-hand side are the constraints. All right, those represent the lines that we want to graph, the inequalities that we want to shade. All right, from there we'll find our vertices. From there we'll find our x and y values. Once we have our x and y values, we'll plug those in to our 6x plus 3y, and we're going to see, because it says maximize, we're looking for the largest number that we can get. Do we follow that? All right, so I'm going to kind of run under the assumption that you guys have these lesson number, or have this picture up on your screen. So I'm going to move over to a coordinate grid where I can actually graph this. Okay? Now, let's see. Our first equation was x is what? Less than or equal to, greater than or equal to 0, right? Okay, so the first thing I want you guys to understand is that x equals is what type of line? What type of line is x equals? Is it horizontal, is it vertical, or does it have a slant to it? It's vertical. All right, so x is greater than 0. X equals 0 is also known as what? Where does that happen at? X equals 0.
At the origin.
At the origin, but it's a line, so it's not just a point, right? The origin is a point where the x-axis and y-axis meet. So x equals 0 is what?
It's just the line on this line.
It is the y-axis. Okay, x equals 0 is the y-axis. Now, this is an inequality, so which means we're going to shade one side of that line or the other. Because it's x is greater than or equal to 0, what side am I shading, the left side or the right side? It's greater than 0, the right side. So all I'm going to do for now is I'm just going to make one arrow so I can remember, okay, I'm shading to the right of this. Then they gave me another equation, right? It was y is what, less than or equal to 5. Well, if x equals is a vertical line, then y equals must be a, what kind of line? Horizontal line. So here I'm just going to count up 5 from the origin. 1, 2, 3, 4, 5. Okay? And that's going to be my line across. Now it says y is less than or equal to 5. So am I shading above or below that line? Below. Okay? So I'm going to shade below that line. In fact, because I want to use some of this space over here, I don't quite need all of that. Let's give myself some more room. Okay? All right, now I've got a couple other equations. Can somebody read off the equation that exists below that? Manuel?
X plus 5, x plus y.
X plus y?
Yes.
Okay. X plus y?
Less than or equal to
10. Now, what I can do with this is, if you remember this, I don't know how well that green's going to show up, but we can actually do those x and y intercepts. Do you guys remember the x and y intercepts from yesterday? Okay. All right, what did I do? Like, if I wanted to find the y-intercept, what did I plug in for x? 0. Okay, so let's plug in 0 for x. 0 plus y is less than or equal to 10. So what does y equal? It should equal 10, right? Less than or equal to 10, so y would equal 10 whenever x equals 0. All right, if we want to find the x-intercept, we're going to plug in 0 for y. So what is x going to be? Well, if that's 0, x is less than or equal to 10, so it would be 10, right? All right, so we got 10s. All right, so let's count up here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, and I could draw a line. Okay, it's going to go across like that. All right, because it says x plus y is less than or equal to 10. What side of this line am I going to shade? What do you think? The up and to the right or down and to the left? Down and to the left. Okay, you're right. Okay, and we could change that over to slope-intercept form, right? We could get y is less than or equal to negative x plus 10, and then plug in 0 and see if we're going to include that. Of course, 0 would be less than 10, right? If we plugged in 0 for x, we would still find that, so we'd get 0, 0 would be part of that. All right, so I'm going to erase this here. What is we're probably going to go back to, let's go to a blue line again. What is the next and last inequality? Less than or equal to 8? 8. Okay, so we can do this again. We can do our x and y again. If I plug in 0 for x, right, then I've got negative 2y is less than or equal to 8. What would I divide 8 by? Negative 2. What's 8 divided by negative 2? Negative 4. So if x equals 0, y equals negative 4. Let's plug in 0 for y. Negative 2 times 0 is 0. So that would be, if I plug in 0 for y, what do I get for x? It'd just be 8, right? Just be 8. All right, so I can get those. Let's see. If x is 0, we'd be at negative 4. 1, 2, 3, 4. Be right here. And if y is 0, we're going to be over at 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay? So we're going to get a line. Oh, it's not great, but it's something like that. Okay? Now, this one's kind of difficult because we do have to find out where we're going to shade on which side. Okay? So for now, let's go ahead and do this for ourselves, just so we're clear, we don't mess anything up. Let's go ahead and change this over to slope-intercept form. This would be negative 2y is less than or equal to negative x plus 8. And then we would do what? We'd divide by negative 2. Right? Is that going to do anything to our inequality? I'm dividing by negative, so it's going to do what? Change the sign. So y is going to be greater than or equal to 1/2 x minus 4. Okay? Okay? So, because y is greater than this line right here, okay, we notice that it does work. We go up 1, we go over 2, up 1, over 2, up 1, over 2. We should get back to where we started. Our y-intercept is still at negative 4. What side of the line am I going to shade? Am I going to shade up and to the left or down and to the right? Up and to the left. Okay? Which means that in here is my shaded region. Does that make sense? All right, now we need to look at our vertices. We have a vertex right here, one right here, 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 and here. Okay? We have this coordinate, this first one, is at 0, 1, 2, 3, 4, and 5 are my constraints, my constraint coordinates. 1, 2, 3, 4, 5. So we have a place at 0, 5. We have a place here at, let's see, 1, 2, 3, 4, 5, 5, 5. Okay. We've got a place over here at 0, negative 4. We've got another place right there. Let's see, 1, 2, it should be at 8, 0. And then we've got this mysterious guy right here. And that's going to be important to us. Okay? All right, so let's see if we can find out what the coordinates of that position are. Okay? So what we're going to do is we're actually going to take these two equations together, and we need to solve for their x and y. Right? All right, so let's do this. The easiest thing to do is just to subtract them, correct? Because x minus x, my x's would cancel out. Okay? But what is y minus negative 2y? No? 3y. Why 3y? Double negative. So it's 1 plus 2y. So I get 3y, okay, is less than or equal to, what's 10 minus 8? 2. What do I need to do with the 3? By on both sides. All right, so y, and essentially, because we're really not looking at the inequality portion here because we're looking for a set of coordinates, y equals 2/3. Okay, so this coordinate here, so far, the y is 2/3. Okay, how do I find the x value if I know y equals 2/3? How about we plug 2/3 in for y? Is that what you said? No? Okay. So let's come to this, let's go to the first equation. X plus 2/3, and let's just say equals 10. Okay, we want to solve. So what do I need to do with 2/3? Subtract 2/3. Okay, well, because one's a fraction, one is not, I would normally get a common denominator, and if that would be thirds, right? Okay, this is 2/3 over here. In order to get 10 to have a denominator of thirds, I'd have to multiply it by 3 on both sides, which would give me 30 thirds. So what's 30 minus 2? 28 thirds. 28 thirds. All right? So do we understand how we got 1, 2, 3, 4, and 5 coordinates? Okay. So I'm going to have you guys hold on to those coordinates for me. I'm going to come over here. And what was our equation that we needed to fit inside of? It was like 6x plus 3y, right? We wanted to see which one would give us the greatest value. All right, now do you guys have the coordinates for those 5 sets of coordinates, right? All right, so let's do the first one. 6 times what? What's the x coordinate of the very first one? Probably 0, right? Okay, 6 times 0 plus 3 times 5, right? Okay, well, that's just going to be 15. Okay? Then we're going to take 6 times, what's the next one? Is it 5? Okay, 6 times 5 plus 3 times 5. Okay, so I've got 30 plus 15. I should get what, 45? 45. All right, then we have 6 times, what's next? 6 times 0 plus 3 times, okay, so you're dropping down there, that's fine. So 6 times 0 is nothing, so actually here I get what, negative 12? All right, so that's not going to be a very high value. All right, 6 times, anything else? What? 6 times 8 plus what, 3 times 0? Okay, so that looks like what, 48? 48. Any others? Okay, so let's come over here. 6 times 28 thirds plus 3 times 2/3. All right. Okay, so that's going to be a bigger number, right? Well, at least in terms it's going to be a little bit more complex. What's 6 times 28? 168? All right, 168 divided by 3. Can anybody tell me what that is? 56. All right, and 3 times 2/3. Well, 3 times 2 is 6. 6 divided by 3 is 2, right? So that's giving me a total of 58. Right? Is that the maximum? Yeah, that gives me the maximum. Okay? So what we're looking for is we're looking for an answer of 28 thirds and 2/3. So it would be B. Okay? Does that make sense? All right, so yeah, with the other class, I kind of struggled to get all of that together and make it presentable so that you guys could get something out of it. So hopefully that turned out a little bit better than it did with the other class earlier today. All right, now we're going to start looking at probability. And before we really say very much, I want you to understand 2 things. I only really need you to get 2 things today with this. Probability. Okay? What is it? Probability is this. It is the number of desired outcomes, and we can make that bigger, over the number of total. Okay? The number of desired outcomes over the number of total outcomes. Okay? That's probability. So if they ask me for probability, I'm going to be looking for how much am I dealing with and how much of it is what I want. Okay? Now, we also have something else that we work with, which is something called odds. right? Those of you that, I don't know, I think we're far enough out that the things that kids were into that I remember, man, the kids are really into that right now. Now, like, you guys don't even care about any of that stuff anymore. So, like, the Hunger Games. How many of you ever read the Hunger Games? Right? The lady didn't ever say, may the probability be ever in your favor, right? What did she say? May the odds be ever in your favor. Now, granted, she wasn't speaking mathematically, probably, but, okay. Odds is different. Odds and probability are not the same. They're not interchangeable. We can't flip them. We can't flop them, okay? Probability is the number desired over the number of undesired. Okay? And it's not spelled at all correctly, but underrated. That's why I don't teach language. Let's at least try to spell that right and try not to erase it as we go. Number of undesired. Because I know you care about the spelling. Okay? Now, question number 3 up here really takes this to kind of a whole different level. And so we'll look at how to answer this question. But the rest of these are going to be much easier than what number 3 is going to be. Do we have these notes written down for this? Great. Okay, I'm going to clean this up, and we're going to look at question number 3. Question number 3 says, in a recent survey of 25 voters, 17 favor a new city regulation, 8 oppose it. We will know what the probability in a random sample, and it's the whole random sample thing that makes this more complicated than normal. The random sample of 6 respondents from this survey that exactly 2 will favor the proposed regulation and 4 oppose it. Express your answer as a decimal rounded to the nearest hundredth. This is how we do this. We actually have to include combinations, all right? Because you see what they're trying to do here is that there were 25 voters, and obviously out of those 25, 17 were for it and 8 were opposed it, so it would have passed, right? So if you look at what they're trying to do here, they're going to just pick 6 of them, but notice they only want 2 to favor it and they want 4 to oppose it. So they're trying to figure out, hey, if we picked a random sample out of the people who voted, could we pick 6 people so that it doesn't pass, right? You see how they're trying to like kind of mess with the numbers. All right, so this is what we end up doing. Because we want number of desired over number total, okay, find my information here. Okay, we're going to take a look at 17 to 2 and 8 to 4. So what we're going to do is we're going to say 17 C 2, okay, times, let's see, 8 C 4, okay, and we're going to put that over, because we want the probability of this happening, okay, and we're going to put that over 25 C 6. So what you should see here on the top, okay, is how many we started with, but we only want specifically 2, okay, times, well, we had 8 opposed, but we only want specifically 4, over the total. Well, the total is specifically 20, or was originally 25, but specifically we're looking for 6. So what we're going to do is we're going to take our calculators, okay? And you can see how it's been worked out up here. I'm going to show you, this is like on those cooking shows where they tell you how to make it, but it's going to take like 4 hours in the oven, and so boom, hey, we've already got one cooked. That's what it's going to look like whenever we're all done. Okay, but that doesn't necessarily help you, so let's go ahead and try to do this. I have to, because it's an older calculator, go ahead and hit the number 17. I'm going to go to math, okay, right underneath the alpha button. Go over to probability. I go to the left to get to the right. Go down to 3.
Hold on.
You're going to wait.
Okay, so hit math.
Hit math.
Probability. Okay.
All right, so you got your parentheses. You got your 17. Okay, so you're dealing with the calculator just like mine. I'm going to move this over so that I can actually see. All right, we're going to hit 2. Okay, now the times button. 8. Math. Probability. NCR. Close parentheses. Because we want to divide all of that by the same thing. Okay? That's why we put parentheses on both sides. If we don't do that, very good chance we're not going to get the right answer. Divided by, and for safety's sake, I'm going to go ahead and put parentheses around this just to make sure no funny business happens. 25 NCR 6. It's going to make sure that I divide by all of that. Oh, what went wrong?
You forgot the 4.
I forgot.
4.
Ah, I did. I got to clean that up. All right, so we'll just do this real quick. 17, probability. Up one. What was that? 2? Times 8. Math. NCR. The problems with going live. You get to make these mistakes in front of everybody who watches this later. Let's try this again. Boom, there we got it. Okay? So, now granted, maybe, even though because you're sitting in this class and you're watching it, yada, yada, doesn't mean don't go back and watch the video later, because if you see a question like this, chances are, hey, am I going to remember exactly how to do that? Maybe not. Okay? All right. Let's go down. Let's look at some easier stuff here. Okay, let's look at this question right here. All right, the probability. Okay, so probability. Do we remember what probability is? Right, what goes on top with probability? Not derided, but desired, right? Over the number of total, how many I actually have. The probability of drawing a green marble from a bag is 40%. Okay? What are the odds in favor of drawing a green marble? So what we actually want to do is we want to take that 40%, right, because it's probability, and let's turn it into a fraction. But before we do that, we need to turn it into a decimal. So 40% is what? What is that as a decimal? 0.4. All right? What is that as a fraction?
4 over 100.
Not 4 over 100, 4 over 10, because this is 4/10, right? All right, so that's the probability, 4 in 10, which means the number desired is 4, the number of total marbles is 10. Okay, you follow me? Okay, so if I want odds, what are odds? All right, so does the number of desired change? No. But the bottom number changes because I don't want the total, I want how many are not green marbles. Well, if 4 of them are green, how many of them are not green? 6. So the unsimplified fraction is 4/6. Let's take that on down and say that the odds are 2/3. Okay? Okay? What are the odds in favor of drawing a green marble? Okay, 2 and 3. Or, there's 2 for, there's 3 against. Okay? So we understand probability and odds a little bit better now. Okay, they're not the same. Okay, so actually, with odds, we need to find out how many are not what I want. Yeah, I subtracted. Okay, does that make sense? Okay. I'm trying to be more careful about, with the recording, that I'm not saying a lot of names because, I don't want anybody to feel like they got bullied and now everybody's hearing it. Did you listen to this YouTube clip? Somebody didn't know the answer.
I heard you bullied someone the other day.
You did? Did I bullied somebody? Not me. Not me. All right, so this goes back to our linear programming. It actually do most of the work for us, okay? Because one, do I need to draw the graph? Do I need to draw the lines? Right? I don't need to do anything, right? In fact, they give me my function up here. They even give me my vertices right there. Now, we want to find the maximum. So, I'm going to start off 35 parentheses plus 60 parentheses. All right, what am I going to put next to that 35 to start with, just to try? 2, and next to the 60, 4, okay? So it looks like 70 times, 70 plus 240, something like that. What was that, 310? You can try it, check it out.
Yeah,
310. All right, 310. And just kind of like a general rule, if I'm going to get 0 for half of the question, chances are the one that has 2 whole numbers is probably going to be the maximum. But let's just see. We got 35 times 0, which we know is going to be 0. Okay, so all we're really getting out of this is 60 times 5, which is 300. Well, that's still less than 310. And this one's going to be 35 times 4 plus 60 times 0. So we're not going to get anything out of that. So really just 35 times 4, 140. So my maximum is 310. Okay, we feeling a little bit better about some of those? Everyone said yes. You can't hear it, but they're all clapping, saying, he's the best. We've never had a math teacher so great. Just not everything picks up on the audio. I apologize if you're listening. Yes? Orange? It turns orange for a little while, but it is on because there's numbers on there. So thank you for making sure that I'm recording, because that has happened. All right, probability. Probability is what I'm looking for over the whole thing. Sometimes we're talking about area, right? I want to know the probability of throwing a dart and hitting the shaded region. Well, I need to know the area of the shaded region. What shape is my shaded region here?
Triangle.
Triangle. How do I find the area of a triangle?
It's squared.
No, that's Pythagorean theorem. You're getting some base. I hear that. A base. How about base times height? Divided times half or divided by 2. Base times height divided by 2. What's 2 times 4? 8, right? That would be my base times my height. 8 divided by 2 is? 4. All right, so the area of the shaded triangle is 4, right? That's my desired area. All right, how would I find the total area? Adding what? The two areas together? Yeah, I could, although that seems maybe like making things more difficult to find the area of the trapezoid and the area of the triangle and add those together. Could I just find the area of the rectangle? Yeah. Okay. How do I find the area of that rectangle?
Base times height.
Base times height, right? It's not a prism. So what's my base and my height here?
13.
What's 13 times 4? 52. All right, well, that seems like it'll probably simplify to what? Maybe like 1/13th? 1/13th. So my probability of throwing a dart and hitting that shaded region is 1 in 13. Okay, we solved it. Everybody rejoiced. There was peace in the land. Okay. Okay, what point gives the minimum value? All right, that's the important part to make note of, that we're not looking for the largest number, we're looking for the smallest number. Now, we should be good enough to look at our coordinate pairs, right? Should be able to see. The first thing I'm going to do is I'm going to identify what are the coordinate pairs. All right, it looks like 1, 4 here. Looks like 4, 4, 1 there. Here I've got 2, 0, and up here I've got 0, 1. Okay, and I'm going to plug those values in for what? X and Y in which function? What's the 3? Okay, so we're going to start with 3 times 1 minus 2 times 4. Okay, so I'm going to start there. So that would be 3 minus 8. Negative 5. Remember, we are looking for small numbers, and negative numbers are small numbers. All right, let's try 3 times what? 3 times 4 minus 2 times 1. 12 minus 2, which is 10. Okay, 3 times 2. 3 times 2 minus 2 times 0. Okay, what's that? 6. Okay, looks like what? We've got one more. 3 times 0 minus 2 times 1, which is negative 2. All right, so looks like 1, 4. 1, 4 is going to be the coordinates right here. So this is what I told the other class. One of the things you want to notice is don't assume you can't look at it visually and guess which one is going to be minimum or which one's going to be maximum. Does that make sense? Because look, if you had to guess, wouldn't you have said 1, 4 is going to give you a maximum value? But because there's a negative in my function, right, that multiplies that number by a negative value, giving me a much bigger small number. If that makes sense. A big small number. All right. Here we go. All right, let's be done for today. I think that's enough information with probability and odds in linear programming for you guys to get a good start and have your homework done tomorrow. What else is due tomorrow, class? Review. All right. Good luck. We'll see you tomorrow. And as always, do math, not meth. Like and subscribe. Click that notification bell if you want it. Leave a comment in the section below.